So lesson 3.3, solving quadratic equations using square roots, is the goal of today. So what we're looking at is basically we need, in order to be able to use square roots, we must get it into vertex form. Okay, that's the only way it works because we can't solve with a square root when we have that middle x term. So that's kind of the why behind all of this. So our steps, once we have it in vertex form, we need to isolate the squared term. Then we need to take the square root of both sides, okay? Both sides. Okay, the square root of a positive real number can be positive or negative, so there's always two possible solutions. Okay, so either the positive end or the negative end. So you're going to see a symbol that looks, let me see if I can get it to show up well here, like this, plus or minus. Okay, that's indicating that it could be one or the other. Okay, and then you must always check that these actually work when we plug our values back in. So let's try it out. Example 1, solve for the variable in each of the following equations, x squared equals 9. So our x squared term is already isolated, it's by itself. Okay, and remember, solve means that we're wanting to end up with a statement x equals something. Okay, and get everything else away from it. So to undo a square, we take the square root. Okay, and those almost essentially cancel each other out. The square root of 9 is 3, but it could be positive or negative. Now we need to check. In this particular case, there's no real restrictions, so it's not going to cause us a problem, but just to get in the habit, we've got positive 3 squared equals 9, that's true. We've also got negative 3 squared equals 9, also true. Okay, so both of them work, so those are my answers. In this case, my squared term is not isolated yet, so that's my first step. I'm going to move that 1 in order to get my x squared term isolated. 6. I'm even going to move the 2. So x squared equals 3. Take the square root. And I end up with x equals positive or negative the square root of 3. Now in this case, I'm not going to actually change that because we can do a decimal because there is really no need. I want an exact value. You'll find that the farther you get into pre-cal and calculus, the more exact values are helpful instead of converting it to a decimal form. So we're just going to leave it like that. And then we're going to plug it back in to check. 2 times the positive root of 3 squared minus 1 equals 5. Well, that equals 2 times 3 minus 1, which equals 5. That works. Then I've got 2 times negative root of 3 squared minus 1 equals 5. If we simplify that, 2 times 3 minus 1 equals 5, also true. So they both work. I'm good to go. Still nothing extraneous coming up. Last one, because both of these pieces are under our square, they're inside the brackets, and then the square is applied, we actually have to treat this whole piece in the square, which means that I'm going to take the square root before I start manipulating it around. Okay, so I need to get rid of the square so I can remove those brackets and work with x minus 4. Equals the square root of 12. Now, if you're comfortable with radicals, and it's a good thing to practice, you might be able to spot that 12 breaks down into 4 and 3. So I could even rewrite this as x, don't forget it's plus or minus. So that would actually simplify to be 2 root 3. Then I would move this 4 over by adding it. So I end up with x equals 4 plus or minus 2 root 3.